Alright, here's the latest state of the computer for the Jeep. Got the front panel, which I believe everyone has seen before, at least those paying attention to this. And here is formally the contents of that enormous breadboard. And I believe there's a technical term regarding the PCB construction I've employed here, and I think that technical term is pushing your luck. So I'm not sure if it's very clear on the video, because it looks like I can only get about that close with it without having the focus go out. But this is the GPS, the Teensy 3 with a few modifications that I've used for host detection and programmatic reset. Here we have a BMP 085 barometric pressure sensor. This is a 80XL 335 analog triple axis accelerometer, which is I'm using as an inclinometer. That's a TMP 102 I2C temperature sensor with a little jumper here that plugs it into the rest of the I2C bus. Way up here, hiding under this, I'm going to just unplug this. Under there we have an I2C EEPROM 32K. I'm aware that the Teensy has its own inbuilt EEPROM, but it's only 2K. And I will use the inbuilt EEPROM for storing settings and whatnot, while I'll use that EEPROM for storing other data, which I will get to momentarily. There's a circuit here. I need a flashlight. Where is that? There we go. That's better. Let's not wash it out. That's no hope. Can't read it. Alright, so this chip over here is a 74HC123. It's a dual one-shot. One of those one-shots I'm using to reset the Teensy, and the other one shot I'm using to hold power to one of the MOSFETs that's going to be off board while the Teensy is possibly rebooting. So underneath this, right here in the dead center, we have another 16-pin DIP, which is a 74 LS138. That's the demultiplexer that selects between all the different SPI devices I have on board, and I've used every pin of it. So all 8 pins are accounted for, and one of those chip selects is the global reset for all of the SPI related logic. On the far left here, I have a 74 HCT 595, which is driving a series of MOSFETs that are off board. It's also providing the reset trigger pin here, and 3.3 volt regulator, filtering capacitors, terminal block on the bottom. On the left, we've got a 26-pin IDC connector, which is the connector for the front panel right there. That's all the major components. There's a variable resistor for PWM output volume for the PWM. Assorted transistors, and then the underside. I managed to keep the loose wiring to a minimum. You can see I've tacked a couple capacitors, and probably isn't going to come out in the video, but the surface mount resistors that are interspersed all throughout these traces. Up here we have the connector it's a single row dip header that's going to plug into the audio switch circuitry that I'm going to show you momentarily. And that's all I have to say about it for now. I'm going to take some video of it running.